All right, everybody, we are about to get started in about 45 seconds. Nothing big, nothing too formal over here. We're just going to be doing a little bit of CG and having a little bit of fun on this Sunday. Welcome. Hope you guys can all make it. All right, all right, all right. Let's go ahead and get started. It's only us for now, but I'm pretty sure more people will join. Welcome to my first live streaming here that we're doing. This is a new thing that what I'm trying to do. I'm trying to do this just to get used to doing some live casting, and also to try to share a little bit of things that I figure out, or how I go about doing some CG, or how about go about writing some tools. Today we're going to be talking a little bit about the software development process. Basically, when you're trying to build tools, there's many different ways you can go about trying to build your software. And through time, I have, and through a lot of trial and error and reading, I found different ways in which you can make sure that that your software is not prone to a lot of design mistakes where you have to go back and rewrite the software, which is something very common when people first get started writing. But let's go ahead and let me see, just to make sure that everything is working good over here. Okay, so like I said, this is called CG and Beer on Sundays, or Sunday CG and Beer, and it's just going to be me having a little bit of fun, doing a little bit of CG and enjoying a beer. So today's one is brought to you by Stella Artois. I think that's how it's pronounced. It's not really brought by them. They didn't give me any money at all, but I like their beer, so we're gonna have a little bit of it. Let's go ahead and get started. Very aromatic. All right, cheers. Okay, so what are we going to go over today? Like I said, it's all about software development process. So let me go here to my little website, and this is a write-up I did a while back, and I'm just going to go ahead and share it here with you guys. So basically, one of the things I'm going to do to try to show the process, I'm going to go through the process of writing a full tool. What we're going to try to write is going to be a Material X exporter for Blender 3D. And for those of you who are not familiar, Material X is this little project right here. And basically what it does is it creates a file interexchange format that you can use to move looks from one application to another. It's just a specification, kind of like how Rib was for RenderMan. And it's up to developers to make sure that they write tools that can read this specification and then use it inside of your software that you use for content creation. So we're going to try to create one of these for Blender. And the reason I chose Blender is because open source, and I think it's really great software. And it's pretty easy to get in there and do things. So we're going to build that for Blender. And I wanted to really quick just go over the process, right, of trying to do this. So, cheers. My good friend Varomix is online, or Varomix, like he calls himself, and just cheers to you too, brother. All right. So, one of the first things that I usually like to do whenever I'm going to approach a project, and full disclosure before I begin, this is not the only way to do it, and there might be a couple of things that I do a little bit different, but this seems to work for me. So I am, by no means this is set in stone, or is it the best way to do it. It's just what works for me. So usually the first thing I do is I go into a stage that I call problem analysis, which is basically where we're going to try to make sure that we understand what is it that we're trying to build. You would be surprised how many times people kind of already have an idea of what they want to make, and with very little thought behind it, they just go ahead and try to start writing things. And this is very exciting because once you get an idea in your head, all you want to do is put it on paper, or get it done. But I have found that a lot of times you end up making some mistakes or bad assumptions of what you were trying to do in the first place. It's very easy to have a target and then really easily lose that target and start working on something else because you didn't really define very clearly what is it that you were trying to do. So the first things we usually do is do the problem analysis. Basically, what are we trying to do? In this particular case, we're writing Material X, import exporter for Blender. So in another video, we're going to go into a lot more detail, but usually what you want here is just a very clear statement of what is it that you're trying to build. Once you know what your problem analysis is, the next thing to do is to do your spec writing or your story gathering. The story gathering is something that is very common whenever you're using Scrum, and it's what I prefer for my spec gathering because specifications can be very complex, they can be very detailed, and they can take a very long time to put together. And a lot of times these specifications, once you start getting the product in front of people, it turns out that it's not exactly what they wanted, or it doesn't exactly fulfill their needs. So whenever I'm working on things, I like to do what's known as stories, and stories comes from, they're used a lot in Scrum, which is a development methodology. And basically what it does is it doesn't really concern itself with explaining how things will be done. All it really cares about is what is the final use for the user. So for example, instead of having to define the functions or what kind of return data a piece of software should do, in a story you will do something like, for example, for Material X, you would do something like, as an end user, I need to be able to import Material X files into Blender so that I can use their looks. Something as simple as that, right? So it's very interesting because with a very simple statement, you express who needs it, what are they trying to do with it, and why they need it. So those three things let you know kind of what you need to do in order to satisfy that story. Now, a lot of times the story might become a whole bunch of more stories later on, but it's a good starting place. Next, once you have all of your stories ready, you usually, if there is a need for a user interface, because sometimes you're going to be writing tools that are just batch script, but if you are doing anything that has a user interface, you want to do a little bit of UI prototyping. And this is something where a lot of times I will use Balsamiq or sometimes just good old Photoshop, right? So you just want to kind of visualize how is this tool going to work, how is the artist or the end user is going to interact with your tool. This just gives you a lot of information on sometimes on how you need to structure your code, or what are the different things that you're going to need to do to make things work. Now, once you have your stories, which tells us what is it that we need to do, once you have your UI prototype, which tells you how we're going to present this to the end user, with those two, you're usually able to go into the software design stage, which is where you're going to go ahead and start laying out what the different classes are going to look for your software. Functions, sometimes you don't really rely a lot on classes, but more on functions, how they're going to interact, and you just start laying down the foundations of how things are going to work out. Now, this particular stage can be challenging for people, mainly because it takes a lot of forward thinking. Right? You need to be able to think about how the software is going to work as a whole without really sitting down and typing away, the code. And for a lot of people who are new, this is really hard. Actually, in fact, it's really hard for someone that's been doing it for a while, as you guys will see when we start trying to break things down. But it is very, very useful because a good design will allow you to not waste time coding things, just left and right. Because when you jump right into code, a lot of times you'll realize, oh, I code myself into a corner. I need to figure out how to make things work. A good design will allow you to not do that, and be a lot more efficient with your time. Usually, after you're done with your design, so by now you have your stories, you have your user interface, and you have your design of how you think your software is gonna, the different pieces that you're gonna need to make your software. At this stage, I usually like to go into what I refer to as exploratory coding or R&D. Now, before I go into that, let me take a little more of this guy. Nothing like doing a little bit of CG and enjoying a beer on Sunday. So let's see, exploratory coding. Every single project that you work on, it's almost always going to have certain parts, certain components that are not, they're not crystal clear on how to do them, right? You either have not dealt with this in the past, or you're going to be dealing with some new libraries, some new technology that you might not be 100% sure of how they're going to interact together. So you use your design that you did a little bit earlier, and you start doing a little bit of coding for those parts that you're not completely sure about. This is very important because a lot of times you're going to realize that your design that you did earlier on with all that forward thinking does not really apply, because just there are functions that return data in a different way, or there's just different interfaces that you have to use. So a lot of times after doing a little bit of exploratory coding, you're going to have to go back to your design and redesign things a little bit now that you have better understanding of the problem that you're trying to solve and the tools that you're going to use to solve them. And this is gonna cycle, right? You're gonna do this several times. You're gonna go forward, you're gonna go back, and eventually you're gonna be able to arrive at something that feels like it's ready to be developed, which at that stage will take us into development. So in development, this is it, right? This is where we're gonna go ahead and put on our headphones, jam some music, and just start punching away into the keys all of the code that we have been, preparing to write all this time. It is the most fun part because you finally see things come to life. And if you have done the previous stages well, you should not waste a lot of time. There's not going to be a lot of back and forth where you move forward and then you realize, oh, that's not how I want it, or that's not how it's going to work, and you keep going back because you took the time to do a lot of planning. Once the software is done, usually you are going to go ahead and prepare it for release. Now, this is something where I think a lot of TDs sometimes they just I don't want to say that they get lazy, but they're just hastily wanting to put their tool in front of people, right? We want to make sure that we share all this awesome work we've been doing with people, and a lot of times they will not provide the necessary documentation for what they've done, either in the form of a end user documents or in source code documentation. So it's always important to make sure that before you've been working on this piece of software and you want to put it out in the world, it's always good to take a little bit of time and make sure that you package it nicely so that when it is used by the community, they can jump in right ahead and start using it without having to figure out what is it that you were trying to do. And the final stage in most tools is going to be maintenance, right? Regardless of how good you are as a developer, I've never met one single developer who is never never made mistakes. So there's always going to be either bugs in there or there's going to be feature requests for improvement, and that is going to be something that you have to kind of keep in mind, and you have to make sure that you can go back in there and fix the software in a way that you're not introducing more issues or more bugs into the system. To do this, we are gonna rely on a development. I don't know if it's a strategy called test-driven development, right? And test-driven development, basically, what it does is it makes sure that as you're building your software, you're constantly testing things through software also in a way that is repeatable, and that it can be so that whenever you make any changes, all you have to do is run your testing suite, and you are reducing the amount of the percentage. You're reducing the amount of errors that you can introduce into the software, because basically you're making tests all the time. This is something that happens very often. You write a piece of software, it works, then there is an update that has to happen. You go over here to a different file, you make the changes, and everything looks good, everything works fine, and then you forgot to test, or you forgot to remember that this code change is going to affect something that, you know, gets used probably 10% of the time. And it's going to go out there into the public, into the world, and then before you know it, someone's going to try to use it. Oh, your software's broken, and you know, it creates problems. So whenever you have a testing suite, you are able to, okay, I made all my changes, I'm going to run my testing suite, and you're going to be sure that you didn't break a feature that was not as commonly used and that you were not testing by hand. And besides, it also reduces a lot the amount of time that it takes to develop, right? Because once the code is out there, every change can introduce bugs, and you know, if you spend a lot of time trying to test things manually, it's going to be very expensive. And that is pretty much it, right? That is the stage that we're going to take. So let's go ahead and move along really quick. I'm going to go here to my home page. Let's go a little bit more in detail into the software planning stage, right? So like I said earlier, the first thing you have to do is you have to know what is the problem that you're trying to solve. A lot of times, like I said, people will just jump in and start coding things without really understanding what is the problem that they're trying to solve. And I usually try to do, what I try to do is I try to create a statement, you know, a very simple, concise statement. Hopefully is a single sentence. It might be a little bit longer, but something that explains exactly what is it that we're trying to build. I don't need to go into the details of how or any of the features that it needs to have. I just need to know what is it that we're trying to build here. So I added a little line here, and let me see if I can zoom in so that it reads a little better. All right, well, let's check that out. So this is basically the statement that I came up for this tool. The Material X to Blender extension will allow artists to import, export, and edit Material X descriptions directly from inside Blender, allowing for easy interchange of the look assets with other DCC tools. Right? Very simple, straightforward, to the point, and it lets us know what is it that we want to do, without getting extra wordy or going, you know, off the rails and trying to just starting to do things. Now, with that statement, we usually move over into spec or story gathering. I talked a little bit about this earlier. I want to go a little bit more in detail into this. But here we're going to see a really quick example of what a story is and why it could be useful, right? So for example, you can see my story right here, and what it reads, as a look development artist, I need to be able to export the look associated with an object into a Material X file so that I can import the look into other applications which support Material X. So basically, this would be a story about being able to export this information out from Blender into Material X, right? So what is a good story, or why stories are useful? A good story usually follows the format that you see here, right? As a role, I need, and then you describe the action that is needed, so that I, and then you can explain the benefits of implementing that story. This is very powerful because it will give you context onto, you know, who is going to be using this, what is it that they want, and how is this going to help them. Now, this is usually enough to get started because it gives you enough information in a very quick statement. If, for example, we wrote something like, we need to be able to export looks into the Material X format, it leaves a lot of, there's still a lot of questions out there that need to be answered with this simple statement. Are we doing this as a batch tool? You know, what is it that they're trying to do? Maybe there's a completely different way that they can do this without going through material X. So it is very important that we understand why is it that they want it, and what is it that they want. So a story is pretty good about this. Now, sometimes with a story, it's really good to be able to include as part of the description what I call, or some people refer to as a definition of done, meaning what would I need to do as an end user so that I can call this story as being done. For example, a definition on sometimes is implied, but like I said, sometimes it's implied, but a lot of times it's not. And when it's not, it's good to write it down. So for example, here you could use something like, an artist should be able to select one or more objects in Blender and export the associated looks into Material X compliant document. Right? So let's go ahead and continue. Once we have our stories, we are going to go ahead usually and start breaking things down a little bit. So I wanted to go ahead and move over to a different area right here. And in the meantime, let me go ahead and just put a pause here for a quick second. All right, so let's go ahead and continue. Now that we already did a lot of talking on how things are going to work, or just a little bit of the process that I follow to write tools, let's just go ahead and start breaking things down a little bit. We can, I think we're going to go ahead and start looking a little bit of how I lay out the classes for this tool that we're going to write. So the first thing I did is I found a whole bunch of different examples in the Material X website, and that basically takes me to all these different files here that you're going to be able to see on my browser, right? Each one of these is a Material X file, and this is basically what we're going to be importing into Blender. As you can tell, these are very simple XML files, and they are written by using the libraries that are provided by the Material X project. Of course, you can, this is XML, you can write them however you want, but there's no need to reinvent the wheel. These guys have provided us with APIs for C++ and for Python, and it just makes sense to go ahead and use what they give us in order to be able to read and write this. Now, the first thing I did before I started this is I went ahead and I gave the Material X specification, which is available right here. I gave this a read, right? And when you click on it, it's going to go ahead and bring this big document, which is about 75 pages long, and it covers just all kinds of definitions and how, what nodes can do, how you define properties and parameters, and a whole bunch of different things. But one of the first things I did was look at this diagram, right? And it explains very nicely what Material X does and how it's structured, right? So basically what we have here is on this top part over here, we have textures, right? And those textures are going to be fed into a node graph, and a node graph is going to be a collection of small node operators that manipulate this data in one way or another. The output of the node graphs or the node operators is going to be passed into what is known as a material, right? A material is definition of an appearance, and it's usually going to have a shader with a whole bunch of different node graphs connected into it. Sometimes a node graph can be as simple as a texture, or sometimes it could be a more complex node graph, but they're gonna connect into these material nodes. a material can also be made out of a surface shader, a displacement shader, and sometimes they don't have a displacement shader or a bump shader, but these two things together will define a material. Now, these materials are going to be used sometimes to put together what is considered a look, or what is a look. This look is going to be what is going to be assigned to the object. So the object is never going to have a direct assignment of a material. It's almost always going to be done through a look. And looks are very powerful because it allows you to combine, right? Like you can see on this graphic right now, there's M1, which is material 1, and that is being used inside of the look L2, right? Why? Because L2 might be an object that has, let's say M1 is a rock material, and M2 is steel. So the look 2 is going to contain some objects that are made of rock and some other objects that are made of steel, while the look 1 just contains the rock. It does not contain the steel. So that's kind of how it goes. And then these looks are assigned to geometry, through some of the different nodes and associations, but basically it's the looks that get assigned to the geometry through something that they refer to as collections. Now, this look is going to have some parameters that are going to be exposed to the end user. And there's also going to be geometry attributes that are going to be exposed to the end user so that the user can control the material a little bit. And we're going to look into that with a little more detail later on. So let's keep looking down. And actually, I'm not going to keep going in this document because it gets quite long and quite hairy, and it's a very deep specification, guys. And right now, the first implementation that we're going to do is going to be very straightforward. So let's look at some examples. Right? We have some examples here, very simple ones. First, let me go ahead and take a quick break for beer. Beer break, yay! All right, so let's see. As you guys can see here, the XML file, one of the first things that is going to contain is this material X node here, which basically it's going to, this just qualifies this XML document as a material X document, right? One of the things about this node right here, it tells you which version of the specification it's using, which color management system is using, and which color space is using. Right now we're using a linear space. Then once you're inside this node, you're going to have a bunch of node collections like this one and this one down here, and these are just materials, right? So you can see that the material, every node has a name. And, this material has a reference to some kind of shader node called simple surface, and it has a name. And then here is where you are creating these bound inputs, which have a name, a type, and a value that you're going to create, right? We do the same with another material over here. And then all the way at the bottom, what they're showing us is how a material can inherit properties from another one. So material inherit basically tells us that this whole material, paint gloss, is going to inherit from the material paint flat, which was defined all the way up here. Yes, and with that, we are able to inherit pretty much all of the settings that were defined here, but we're able to override some. So for example, we can override here the specular color and the specular roughness. This way, we don't have to redefine everything. We just have to define the small things that we need to do. So let's look at another example. This one's a little bit more involved, and this one, for example, has a node graph. And the node graph contains an image, like another image. Over here, there's a mix node and a hue shift node, right? So all of these things are going to be wrapped into a single node graph or a single node group inside of Blender, and we have to make sure that we create the proper outputs and the proper inputs for this if necessary. But we are able to see here that now we have nodes that are nested. If we look at the previous one, this one right here, you can see that nothing is really nested, right? I mean, you have a material, and then in here there's like other nodes that are used for the materials, but they don't feel like complete, complete separate nodes that would exist in the Blender scene, for example. A lot of times this is just helping you resolve how you have to assemble the network, but it's not separate nodes that you have to deal with. While on this one, if you're going to try to create this node graph, as you go inside here, you realize, oh, I'm going to need an image, I'm going to need another image, I'm going to need a mix node, I'm going to need a hue shift, right? That's node graph 1. There's another one down here. There's a third one all the way at the bottom. A lot more complex. And basically, that's what that example does. And let's look at one more here really quick. Let me see if this is the right one. This one's a lot more complex. I think this is the one I'm looking for. Yeah, so this one's kind of cool because basically on this one, you have more components, right? We have materials, which we need. Then we have these things called collections, which is basically where we are defining the paths to geometry, and we are assigning them to like a name. For example, C plastic. That is a collection of objects that are named that are going to receive, I guess, something called plastic. But here you can pass a path of different geometry. The paths are defined, as far as I understand, they're defined by using backslashes. Not every software supports this. I think Maya uses pipes to specify hierarchy, but that's something that you're going to have to handle inside of the application. So we have the collections here, and as we go down, we keep going down, you're going to see another node definition. And node definitions are ways for you to define custom nodes, right? Because a good specification needs to be able to account for nodes that are custom, that are not globally available. Maybe what you guys, a lot of studios have their own custom nodes, and if a specification does not allow you to use those, then it's a pretty, it's not going to be too useful, especially for big studios that do a lot of their own stuff. So that's why they created this node definition, which allow you to define custom nodes. And then down here you have property nodes, and once again you get down to looks. Now let's look at the look, because this one is very interesting. Let me try to make this bigger so it's easier to read. Hopefully you guys can see that. Let's see. So as you can see here, we have two looks, right? Look name A and look B. So the first couple of notes. First one, material assign. This creates a material assignment of this look, and we're giving it a name. Like I said, everything has to have a name. This is a requirement. This is named material assignment 1, MA1, and it's going to use the material M plastic, which was defined all the way over here, M plastic 1, right? So M plastic 1, and it's going to assign it to the collection C plastic, which means it's going to be applied to all of the objects that were referenced inside of this collection right here. Same thing with, this line right here is going to assign to C metal. And then you can even do a material assignment to a headlight, where instead of providing a direct collection, which allows you to assign to a group of objects, you're going to assign this to a very specific piece of geometry by just using the geometry tag, right? And then you have another one down here. You have some visibility tags that basically allow you to tell the renderer, hey, this geometry, A/B/headlight, we probably want it not visible to shadows, because it's going to be, thinking about, a model that we worked in the past was the Marine for StarCraft, right? The Marine for StarCraft has lights that are here on the front of their chest, and some are here on the sides of their helmet, and the lights should be part of the look, right? It's going to affect things around it. It's going to affect the glow of the material. So they can't really be an afterthought. It has to be part of the look. And each piece of geometry that is interacting with a light might need very specific attributes set for them. And for this reason, this specification allows you to specify visibility of geometry to the different kinds of rays, such as shadowing, that are available. So that's pretty much all the examples that I wanted to go through. Now I'm going to go ahead and use these examples to try to start breaking things down a little bit. And let's see, we're about 38 minutes into this. Let me take a little break here. Little beer time. And if you guys have any beer that you guys would recommend for me to try, just let me know. And I'll make sure to try a different one every Sunday. For now, like I said, we're going with good old Stellas, which are just nice and crisp. So let's go back here into our user interface. And I'm going to show you a little bit what this is. So this is a UML diagram, which UML can be used for designing so many different kinds of interactions and so many different kinds of scenarios. One of the things that it does is it allows you to create class diagrams for software development. So usually what I do is I'm going to go back here and look at some of these examples, and then use that as a reference for what I'm going to do. Let me go ahead and put on my glasses so I can read a little bit better. All right, so let's see here. The first thing that we have is we have these nodes, right? Materials. So these materials are going to be turned into Blender nodes, right? Basically, for each one of these guys that we find out in our scene file, we're going to have to create a material node. Like I said, the materials are just going to be the different shaders that are provided by Blender, and we have to make sure that we pick the ones that can be represented and are as compatible with other rendering engines as we can find. I think we're going to try to use, there's a very common way of doing look development now, which is where you have metalness and roughness instead of specularity maps. And that seems to translate really well between different applications. So that's probably what we're going to end up with. But as I said, for each one of these materials, we're going to have to create some kind of shader. And the shader is going to be given by this shader ref node, the information down here, right? So I believe it will be very common for inside of this shader ref to have, inside of a material, to have an additional shader ref, for example, for bump or displacement. I don't see an example here, but I'm pretty sure based on the diagram that we saw over here, right, as we can see here, a material can contain different shaders, different shader refs. So this guy could contain multiple shader refs. But still, this allows us to know that every time we encounter a material, we're going to have to drop some kind of node into the system, right? So based on that, I know that I'm going to need a node class. And a node class is just going to basically use all of the information that is included in the material X file so that it can create in Blender a material or a shader or a node of some type. We don't know which type yet. We're not going to go concrete yet. We're going to try to stay abstract as we can. So we're just going to call it node. This just has the ability to read information from material X and then take some kind of action, in the Blender scene file. So one of the things that we're going to have to add to this node, let's see, is definitely going to have a name. It's definitely going to have, it's probably going to have a reference to the material X node. So let's do here matx data, right? And this, we don't know what it is. I think it's going to be a dictionary inside of Houdini. But basically what that's going to be is when we initialize this object, when we initialize this class, we're probably going to pass to it, oh, hold on, this thing got a little bit messed up. And I think this might be too small. Let me go ahead and make this bigger. Hopefully this works better. All right, so we have a node and it's going to have a connection back to material X. So when we create that node, is going to have a connection back to this so that I can traverse down as I need it, you know. So that is going to be our standard node. Now, something else that we realize as we look at this is that there's different kinds of nodes. You have and there's different kind of nodes in how they relate to Blender. For example, this material, once again, it has this shader reference and it has bind input, so it's containing other nodes inside of it at the XML level. But when you think about what it represents in Blender, on how it's going to be used in Blender, it's more of a single node, right? It's going to be a simple shader, and these are going to be inputs or values that are going to be set for it. If we pretend that this MPlastic had also a bump assigned to it, there's going to be an additional shader ref. So that lets us know that this material node might contain one or more subnodes that are going to need to be created inside of Blender. So for this type, we're going to go ahead and we're going to have a node container. And a node container is just like a node, but it can, you know, contain other nodes. And here's where things get a little bit interesting, right? Do I really need a node container? Couldn't I just make every node have the ability to have children? And you could totally do that. And basically that's what we're trying to do here. But because pretty much every node will contain children, right? Collection will well, not really this one, because this collection add is more of like an action. Let's see over here. Property sets, properties, right? So at an XML level, everything can have a children, right? Everything can have subnodes. But remember, what we're trying to build here, we're not trying to build the classes to just recreate the material X you know, specification. We're not trying to create a class to build this or to write this out, because the Material X people, the guys that created that, they already did this. So we don't have to do it. What we're really trying to do is take this and bring it into Blender for doing something. So from that perspective, we are going to basically be creating an abstraction, you know, a little layer that is going to be on top of Material X, and it's going to allow us to take all this data and convert it into what Blender needs. So from that perspective, we're going to have nodes that are just very simple, and then we have a node container, which would basically be like a group. The node container, I think, is going to be a lot closer to what a what's it called, a node graph, to what a node graph is. So let's go back over here really quick, and I see here that let's see, we have this bind input, which basically creates you know, an input for the object. It's not really connected to anything, but it is there. Let's see what we have here. We have node definitions. Whenever we see a node definition, these are going to be special cases, right? Because like I said earlier, these are going to be for custom stuff that we're trying to add to the system. So it's going to be a special kind of node, but it's going to be custom. So it's probably going to inherit from this. So let's look at what else we have. If we go down here, let's look at the look. We have a look, which is a node, and then it's going to contain a material assignment, right? So basically, when we write the look, we're going to need to write the material assignment. So we're going to go ahead and create a new node, and this one's going to be called look node, right? So what's special about the look node? It's going to inherit a lot of the properties from the standard node. And let me go ahead and find the, well, I think there's a way to do that here. Yeah. Right, so this is going to inherit from this guy. So a lot of this information that we're passing in here is not necessary because it's going to be inherited. But there's going to be a need for this class to go ahead and create material assignments. So create assignments. That's going to be a function that is going to need, right? What else is going to need? Is going to need to set visibility. Right? Let's go ahead and make this thing bigger. Bigger. What's this text doing here? We don't need it. I think I messed up here. Let's see. Software messing up with me. Okay, let's see if we can make this better. Okay, so set visibility, and then another one is property set assignment. So we can consider that this is going to have set property. And once again, we're just spitballing right now, guys. We're trying to come up with the different classes that we're going to need. Chances are a lot of this is going to go out the window as we keep exploring, but that's the work, right? It's a lot faster and a lot more efficient to do this right now instead of trying to start coding right away and then realizing, oh, I made so many mistakes because I didn't consider things properly. So we're going to keep doing this, and at some point in probably about 10 more minutes, we're going to go ahead and stop, and then we'll continue next week. And it'll be a little bit more exciting. I know that this one session has been a big talking head, not much of action going on, but it's the first time I'm doing this. I'm trying to figure things out as I go. But more importantly, we had to cover a lot of this before we went into this stage. So I'm going to go ahead and do this, continue doing this, and in another 10 minutes, we'll go ahead and stop. All right, so let's continue. Let's see. What else do we have? We have collection, right? Let's think about the collection. The collection, all it's going to do inside of our specification is going to allow us to group pieces of geometry together so that we can refer to them in an easier way. How does this translate to Blender? Well, we could create groups for every collection that we read that is coming in. Is this gonna mess up our scene? What if the scene already has these groups? Those are things we have to figure out. Maybe we have to put a little namespace to it so that we make sure that we're not colliding with any other groups that are already in the scene. Those are little things that we can do on every implementation, and everyone's going to be a little bit different, but that's basically what they're for. So every time we see one of these guys, we're going to try to create a group. So let's go ahead and let's make a copy of this guy and create a collection. Right, and the collection is also going to inherit from your standard node. Now we're going to clean this up, and we're going to go ahead and, can I do this? Oh, I messed it up. Let's do this again. All right, so now we have a collection, which is going to allow us to create groups. What functions do we need? Let me go ahead and make this big. Oh, the software is acting a little strange. Let's try this again. Huh. Okay, guys, this software is acting up. I'm just going to go ahead and kill this completely, and we'll create ourselves a new class. Let's go ahead and drop this here. And this is going to be our collection. And let's see. Let me move these guys out of the way a little bit. This is just things I've been thinking while I'm working. And a collection is going to have, you know what, this one doesn't really have parameters. So let's go ahead, I'm sorry, method. So let's go ahead and do this one instead. Right, gonna put that guy in there. Select this guy. Boom, this inherits from that. And then this is going to be our collection. And then the method we are gonna, this is going to do, let's see, create. And basically what this is going to do is that whenever we go ahead and create a collection, it's going to create some groups inside of Blender. We don't know any, and we don't care about any details of how that is done or the small specific cases that we have to deal with, but we know we're going to have to, you know, create collections. So we're going to go ahead and just for now, go ahead and put a collection. We don't really need a field here because we're inheriting a lot of stuff from over here. So let's continue. That's our collection. Let's see, a material, like we said, every time we see a material, which is going to be a node, is going to be one of these at least. Every time we see a material, we need to go ahead and write its shaders, because the shaders are what's going to be used inside of Blender, right? There's no concept of a material as far as I know. And then there's always a shader, a collection of shaders. So we're going to go over here and we're going to drag one more of these. We're going to put it here. And this is going to be a material. Material node. And this once again is going to also create. But it's going to create shaders. Why? Because we know that a material can have more than one shader. So we're just going to make it create shaders like that. You see, so hopefully you guys start seeing a little bit of how we are breaking down things. This process takes a while, and it can be long and sometimes tedious, and sometimes you have to go back and redo things. It's quite often that you have to do that. But it allows you to see a little bit. Now, how are we going to deal with the fact that materials can have inheritance? And as far as I know, you know, it's kind of like an instance, but with overrides. So chances are we're going to have to write a little bit of code that that handles that. And there's different ways we can do this, right? We can have it in Blender. We can basically create the pairing node and then just use most of it and then override smaller things, but sometimes that might not work. That's just where I am right now. So it might be worth to just let it go for now. But let's go ahead and look now at the node graph. You guys can see right here. The good old node graph is going to contain a whole bunch of different things, right? Something else that before I continue to a node graph, pretty much every node is going to have parameters. Let's see, these are all parameters here. Node graph. Let's look at our example before. Right, so for example, the shader reference is going to have these bind inputs over here. And this can be thought of as parameters or as attributes that need to be set for this shader ref, right? Same as this one. It has some parameters or attributes. Let's keep looking. This node definition has parameters. This one has parameters too. So most of these guys are going to have some parameters which are going to be shown kind of as they're going to be actions. Like on this case, you know, there's no node that we need to create, that we just have to take a very specific action when, as we're parsing this, when we encounter this line, we have to take a very specific action. Quick second, beer break. All right. So, like I said, some of these guys are going to be parameters. Some of them are going to be actions. So, and that is something that is going to be handled on each one. So, for example, we did that for the look node, create assignments, set visibility, set properties. But chances are, let's see, the set properties, which basically just handles this one, I think, let me see. It might not be, that might not be the right place to put it. But for now, let's just keep exploring and see what else we need. All right, let's go back to the node graph, right? We have a node graph here, which we can, instead of just calling this node container, I'm just going to call it node graph, right? And a node graph is going to inherit also from a node or not. It's going to contain a node. It's going to contain a list of nodes, but it's not going to inherit from a node. I mean, it should, right? It is a node. So it's probably going to inherit from a node and extend it, because it's still going to have a name, still going to have a type, it's still going to have a max, material X data. So yeah, this is going to inherit from a node. Now, a little bit of software design here. Right now, I am doing everything with straight up classes, which means everything inherits from everything else. This is more powerful than just using functions, for example, but it is not, basically you are tying yourself down to the code, or the code how it's been put together at what's called a pre-compile time, right? Basically, once the software starts running, all of the behaviors are already locked in, and from software design, you want to try to, usually you want to break it down so that you can change pieces as the software is running. This might seem a little bit abstract right now, but a way to do that is to start thinking in terms of interfaces, right? So for example, you can create, we can see here pretty much that every node has a create method, right? Even though it's not listed here because they're all inheriting from this, every node has a create method. So what you could do is you could take that create, just the actions that are going to be taken by this object, and move it into an interface which doesn't do anything, but it allows you to define a set of methods that every class which is trying to use, that is implementing that interface, has to provide those methods, right? Basically, whatever node you create is gonna have to have a create method. That way you can use nodes interchangeably at runtime. When the software is running, you're not just going to be tied up to what you did beforehand. You're going to be able to break it down. It makes no sense right now, and maybe it wasn't the right time to go into this. But as we move forward, you guys are going to see me start breaking things out from this standard inheritance diagram where everything just inherits directly, and we're going to have these interfaces, which basically makes things a lot easier when we're running things forward. Sorry, I was not able to explain it as easy right now until we have more information. So I'm just going to go back here really quick and see what else we can do today during this session. Let's see, we were looking at the node graph, right? So the node graph is going to have a whole bunch of different things underneath, right? So what we can do is the node graph is going to have a list of children, which are the subnodes, and then it's going to have a function called create children, which is going to go ahead and create all of these children over here. Now, let's see what else we have. Right, so here we have inputs and we have parameters that are going to be assigned to each one of these guys. Let's see. So for example, we have here a clamp, which has a couple of inputs and a parameter. So does that mean that every node needs a parameter? So I think we are going to need to create another node here that is called, let me bring this guy. Can I select all of them? Oh, these guys are not connected. Let me just go ahead and kill them for now. We'll do connections later. Right, so we have a material node and we have a standard node, but I think we might need another level which is called a shading node. So let me just go here and do shading node. And a shading node is going to be something that takes information from material X and it translates one-to-one to a node that is going to be in our Blender shader tree. So that's its purpose. And it's only going to be used for those kinds of nodes. So for example, a material node has a create shaders, and chances are the create shaders is gonna be used in the shading node in the future. Right, so we have shading node. Let me see if there's a place to where I can put nodes. No, I can't find node. Oh, it has colors. Cute. All right, so we have a shading node that relates one-to-one to something that is going to be inside of Blender, and that's what's going to be like this clamp and smooth steps, inverts, all of this. So one thing that we see here is that they all have inputs and they have parameters, every one of these guys inside the node graph, and that's kind of we wanted to break it. So here we're going to have inputs and parameters. Right, there we go. And then for methods we could have create inputs, do we need create inputs? Don't know, I'm just gonna type in for now. Create input. No, let's do, it's not create because they're going to exist. Set inputs and set parameters. There you go. Let's see. What does this thing do? Oh, I think I got rid of it by mistake. Can I do this? Let's see. Now we're playing with software here, see what it does. Okay, that seems to behave. And then let me see if I can make this smaller. Ah, it's acting weird. Okay, let's do this. Ah, I get it. That's just a separator. Okay, so where were we? Sorry about that. It took a little bit of time. All right. Okay, so where are we right now? We have our shading node, and we know that we're going to set inputs and set parameters. This is going to go ahead and handle the process of reading the information that was here and converting that into a proper value inside of Blender. So that was going to do this. We already have the node container or the node graph, which is going to go ahead and create all the children. In the process of the children, we're going to be creating a whole bunch of shading nodes. So these two kind of go related. Oh, holy moly, I picked the wrong thing. These two guys are going to be related somehow. This is going to be a list of shading nodes. right? This is going to contain a list of shading nodes. I don't think a node graph can contain a material. No, they cannot. So the material node is still going to be separate, and it's still going to need to create shaders, because when we try to translate this into Blender, you're going to have to handle multiple shader references, chances are. It might even be made of more than that, right? You might have a material that's made up of a blend of different materials. So I think this is still correct. We're going to try to create the shaders. And I think that is about it for now. We're a little bit past an hour. I want to be able to do, take a little bit more time and finish this thing up. So I'm going to go ahead and do just that. And when I'm done, I'm going to go ahead and update the blog post where I created this. That is it for now. Thank you very much for joining, and sorry if I was a little bit rambling. Like I said, it's the first time I'm doing this as a live show. Usually I pre-record my things, which allows me to take my time and fix things whenever I make a mistake. That's not the case here. Everything's live, folks. So it might have been a little all over the place. We're going to make sure to make it a little bit better next time, but I hope a little bit of it made sense. We're probably going to do another one more in depth next week when I have this graphic, this class graph broken down and a little bit more farther along, because right now we're just spitballing as we go. So that is it. Thank you so much for joining, and I will see you guys again soon. Goodbye. Cheers.